Hello all. Some of you may already know who I am, but for all the others, let me do a small introduction. Name's Natalia Portillo, but you can call me Nat, and my pronouns are Faye Fair. I'm the CTO of HitSafe, as well as the creator and lead developer of Aaru, and that's what I'm going to talk about today. Please save your questions for after I finish the demo, and I hold a Q&A session then. Aaru is a software package created for the management of the complete workflow of computer storage media preservation, from dumping to analysis and discovery to content extraction. And probably many of you are already using it for dumping but do not know the full power of it. While Aaru works on Windows, Linux, and MacOS, dumping is completely unsupported on MacOS due to restrictions imposed by Apple that we cannot evade, and we strongly recommend using Linux. I understand most people are not used to Linux, but it has several advantages. So, do you hear me? Okay. Do you hear me now? Shall I start from the start, or did you lose anything? Okay, I'll start again. Know that there was some problem with the sound. So as I was saying, hello to all. Some of you may already know who I am, but for all the others, I will do a small introduction. Name's Natalia Portillo, but you can call me Nat, and my pronouns are Faye Fair. I'm the CTO of HitSafe, as well as the creator and lead developer of Aaru. And that's what I'm going to talk about today. Please save your questions for after I finish the demo, and I hold a Q&A session then. Aaru is a software package created for the management of the complete workflow of computer storage media preservation, from dumping to analysis and discovery to content extraction. And probably many of you are already using it for dumping but do not know the full power of it. While Aaru works in Windows, Linux, and MacOS, dumping is completely unsupported in MacOS due to restrictions imposed by Apple that we cannot debate, and we strongly recommend using Linux. I understand most people are not used to Linux, but it has several advantages. While optical discs, like CDs and DVDs, are preferably dumpled on Windows, Linux reacts better to these errors, especially when using USB adapters. However, other kinds of storage media like hard disks, flash drive, and memory cards can be altered or modified by Windows when they are connected, making you create a possibly incorrect dump. Linux can be configured to ignore any connected media easily, ensuring no modifications can occur. For this reason, I'll concentrate this demo on Linux, while everything applies to the other system, merely changing the device path when dumping and how do you open the command line, as Aaru as of now still lacks a graphical interface. The first time you run Aaru, it will connect to internet and retrieve the latest database from our servers. This database allows a better recognition of size of drives when dumping media. So this will take a few moments. It depends on your internet connection, but it's not going to download much data. Oh. You can see everything properly? Okay. So I say this just will take a few minutes, about 1 to 2 minutes, depending on your internet connection. And you see it has downloaded a lot of products, information, devices, and so on, and now it's saving the change from the database. That will take a few moments more. After this has finished, it will ask you some settings and configurations. The first thing it tells you is a disclaimer because Aaru is made in the European Union, so everything that's stored in our servers follow the European Union's data protection laws. And the next thing it is going to ask you is the configuration about decryption. So the thing about decryption of copy protected media is that it really depends on your local laws. So before answering this question, ensure you know if your localhost allows you to bypass copy protections for preservation. It is the case in some legislatures, but it's not the case worldwide. For example, in Spain, it's totally allowed, but in the United Kingdom, it's not. And in case of that, consult your lawyer or directly say no. In my case, as I'm working from Spain, I'll say yes. The next thing is we ask if you want to share the device reports with the Aaru team. These reports have any information identifying automatically removed, so they are completely private. We cannot know who sent them. Unless you tell us directly, we just cannot know. And also, they are manually checked before they are accessible to any person outside of the European Union to remove any information that may have been left. The next questions are about statistics. These statistics, again, are completely anonymous. They just tell us how Aaru is used so we can improve and put more focus on some commands and functionalities. You can just say yes to all of them or no, depending on what you want, but they are completely anonymous. There's no information that we can use to identify you at all. And now we get the help. If you invoke Aaru again without any command, it will just show the help again. Aaru is divided in category action parameters. The most important categories here are device, that uses to talk with device, file systems, that uses to do operation with an image contents, image for operation with media image, and media for operation with the storage media itself. There are other options you can see on the help here, but we will not talk about them right now. So the first thing we'll do is Aaru device list. So we get a list of devices detected in the computer. Here we can see that we have the device path just in the left, the vendor, model, serial number, and so on. And we're going to focus today the demo on this VDRE drive that has a device path of /dev/sr0. So this device path is the one you will want to use to all the media and device commands. It's the most important parameter. And it may change on every reboot, so it's good custom to just do Aaru device list every time you boot up the computer to do preservation. Also to know that for all actions on device or media that are not done over optical media like CDs or DVDs, you need administrative privileges, so you need to prepend sudo to all calls to Aaru. There are not much problem here, but in any case, for security purposes, you should always have a preservation computer that's separate from your network and so on. While Aaru doesn't have anything that can damage your computer, in theory, bugs aside, it's good security because any disk you insert, any pen drive, flash drive you insert may contain virus or other malware. So for your computer that you use to preserve media should always be separate from your main network. So now let's get some device information from this VDR drive using Aaru device info and the device path. We will take a little, and here we have all the information about this device. All the information is sent by the drive itself, so as long as you don't change the drive, it will be the same information. We can see some information about the USB adapter, the drive itself, and some things that the drive is telling about what it supports. Now, because this is a removable, the media, it's really a CD, DVD, or BD, this is a removable drive. The information here is only about the drive. On something like a flash drive of a memory card where you cannot really extract the media from the drive, this is the only information available. But as this is a removable media, we can also use the media info command to get the information that is specific to the media and not to the drive. This will take a little more because it's now accessing the disk I have inserted itself. And here we have information about the media I have inserted. The most important information, obviously, is the size of the media. So this also tells you more or less the maximum amount of free space that you will have or you will need to make the dump. It also tells you information taken from the table of contents, like here. I'm gonna select it. That tells you the track numbers and so on. Also more information about the disk. That's not really important right now. And some calculations about the tracks here that tell you where the track starts, ends, the pregap, and so on, as well as the disk offset. Some preservation groups want to know the disk offset. So this is one way of obtaining it, and we'll see that when dumping it also shows that. So now let's go to the juicy part about dumping. I have inserted a driver CD. As you can see, the information here is identified as a CD-ROM. We show you all the parameters and options that are available when dumping. So to get them, you just do Aaru media dump --help. You can add --help to any parameter, to any category, and it will list you all the commands available in the category and all the parameters that you can change on that command. We see we have here a lot of parameters we can control when dumping some media. So the first one is the CICM XML sidecar. It's enabled by default, and what it does is when the dump is finished, it creates an XML sidecar with information about the dump and the contents of the image. This information is to be used by automated processing software. If your preservation group has some automated processing software, they can support this format to get all information about the dump without needing to manually parse log files. The next parameter, encoding, tells you what's the encoding of the file system contained in the media. This is important to access the files inside if the files have international characters. On most file systems, this can be auto-detected, but on some others, it cannot be. So if you know the encoding, you can use it, or you can just leave it to the auto-detection. It may fail, but most of the time it works. The first pregap option tells Aaru to try to read the 150 sector of pregaps that are on CDs and similar media between the table of contents and the first track. Not all drives can read here, and most cannot read the full 150 sectors. And you do not need them unless the first track is audio, because we're dumping a driver CD, we're just going to leave the default that's disabled. Fix offset, that's enabled by default, is going to fix the audio track's position of the data, because when you read it on different drives, it gets offsetted by some bytes. So this uses the database we got downloaded for our servers at the start to know the drive model and know what's the offset of the drive. So all dumps from the same audio CD on different drives will have the audio on the same position. As said, this option is enabled by default. The fourth option indicates that in case we have put incompatible parameters or parameters that are not compatible with the output image format we're going to use, just continue dumping. With the format parameter, you can specify what output format you want to use when you are using an extension that's not the common one, or an extension that can be the same for several output formats. The trim option controls the skipped sector trimming. When Aaru encounters a red error, it skips several sectors to continue with the dump. Trimming is when it goes back to those skipped sectors and rereads them one by one to ensure which ones are really red errors. The option parameter controls the output image format parameters, and each output image format has many parameters. I'm not going to deep dive on them right now. The defaults are usually very same. Persistent asks the drive to return partial or incorrect data when a red error has happened. Most drives really ignore this, but you can enable it if you have a damaged disk. Aaru will try to detect and tell you if persistent has not returned usable data. Resume controls if you want to resume a partial, incomplete, or stop a dump from where it was left, or if the dump is completely new, creates the file that allows this. There is really no reason to change the enable default. Retry passes tells Aaru how many times to retry on a red error. By default it's 5, and if you set it to 0, it will not retry any red error. Skip tells you how many sectors to skip when a red error is encountered. I said before, it will skip several sectors, not just the one that returns an error, and then go back on the trimming phase. By default, it's 512. Stop on error, as the name implies, will just stop the dump on the first error it finds. Subchannel controls how we want to read the subchannel from CD disk. Any, the default, means to read as much as the drive allows. The other options control which ones we want to ask the drive, and if the drive cannot read the ones we asked, the dump will not proceed. Speed tells the maximum speed we want to read optical disk. Please note that the drive firmware still reduces this value when it finds a red error or some difficulty reading the signal from the laser. So this is just telling the drive, please try to read at this maximum speed. Also, because of the lack of error correction on audio CDs, Aaru will always go to 8 times speed or lower, if you specify a lower value here, to read audio tracks. Private ensures that no information about serial numbers, paths, and so on are stored in the logs or in any metadata that is created. This is if you want to have everything private, contrary to have everything auditable. The next option control about fixing the subchannels, and they are very important to understand properly. So I will, if you have any doubt, please save your question for later, because we have received many questions about how subchannel dumping works on our channel, and these options change how everything is managed. So the fixed subchannel position will store the subchannel on the image according to the sector that subchannel is describing. This is enabled by default and is the only way to get subchannel dumps that are at all comparable between several dump sessions or drives. Retry subchannel will see if the subchannel doesn't look correct, it doesn't pass the error detection, or doesn't look like contains valid data. It will consider it to be retried on the retry pass. The fixed subchannel will see if the subchannel can be fixed. On the subchannel log, it will tell you exactly what has been fixed or not, because sometimes the subchannel just changes one bit and it's very easy to detect and fix. It will not change the error detection on subchannel. That option is handled by the next one. So with fixed subchannel CRC, you're telling Aaru if the subchannel looks okay, but the CRC still fails and tells you that the subchannel is incorrect, fix the CRC. And the last one about subchannels is the generate subchannels. So in case a subchannel was not read without error, Aaru will generate one following the specifications from the Raymond books. It still won't count these subchannels as dumped, so you can still retry to get them from the real media. There's no real problem here. But you may want to have a complete image without holes in the subchannels. The next one is very specific to CDI ready disks, because on CDI ready disk there is a hole, a part of unreadable media between the first data track and the audio tracks. By default, Aaru has this option enabled, that's just skip that, because you can stay many hours trying to read something that's not really readable on any drive we have currently. With the eject option, when the dump has finished, it will eject the disk so we can continue dumping with the next one. Mass blocks tells Aaru how many blocks to try to read at first. Aaru will always try to read that many blocks that default to 64, and on any kind of error it will reduce that until we get a readable point. Use buffer threads is a specific option for dumping multimedia card or security digital memory cards that may not have the multi-sector RAID implemented or supported by your card, the environment, or the operating system. So this way we'll use the operating system calls to read the data instead of directly accessing the memory card. The next option will applies to DVD encrypted media like DVD video, and will just tell Aaru to store the data encrypted without decrypting it. And the last one is to try to read the title keys from DVD encrypted media like DVD video. And when this option is enabled, the dump will be really slow. It can take a whole day, 24 hours to dump a DVD. This is completely normal. We're working on a way to have this accelerated a lot, because the problem right now is that on each sector it's asking the drive for the title keys instead of saving them on cache and trying to see if the title key is correct before asking for a new one. On most DVD discs there are only a dozen at most title discs, so right now we're reading every single sector at title disk. That's why it's so slow, but there is no problem. It will not damage your drive. It will just take a whole day to dump a DVD video. After all the parameters, the first thing you put is the device path that you obtain device list, like in our case, /diff/isar0, followed by the image name you're going to use, with the appropriate file extension for the image format we want to use. It is really recommended you do all dumps in Aaru format, and the valid extensions for it are .aaf, .aruf, or .aaru format. Pick whichever you prefer, and remember to put the image name and extension inside quotes if you use spaces. Now, for the test, as I done a driver CD, I know there is no copy protection, no special subchannel data, and as seen in the media info before in audio tracks, the command line we'll use is sudo aaru media dump --private --fix subchannel position --retry subchannel --fix subchannel --fix subchannel --crc --generate subchannels --eject /diff/isar0, that's our device path, and driver cd.af, so the image name and extension that indicates the Aaru format. Now Aaru will start doing some checks on the drive and media, try to read all parts of the media that are not the user data, and try to detect the media type that has already done on all these lines here. And finally, print some information like the number of blocks, media type, and offsets. If there are no audio tracks, it will inform us that it has disabled the offset fix. It doesn't make any sense if there are no audio tracks. And start reading. As you see, the speed can be variable on this state, dirtiness, error, etc. And you see that the speed is jumping from 4 megas to 1 mega and so on. So now, just let it finish. It will take on this CD about 3 minutes. So after the read phase has finished, it will start the trimming phase. It will not happen on this disk because it doesn't have any error. If you press Ctrl+C on your keyboard during the read phase, the trimming phase, or the retrieve phases as well as during the metadata sidecar generation, it will stop where it is and you can continue the dump later on using the resume file unless you have disabled in the parameters. I'm just backing up a driver CDs from a Hewlett Packard printer. Okay, now you see it has finished. The average down speed has been 11 megabytes per second. And it has retrieved some subchannels and recovered them. It is normal on a CD to get about 1,000 subchannel errors. If you disable the inner subchannel, you will see that it retrieves 4 or 5 or 10 or whatever retrieve passes you have set in parameters. But it's completely normal that up to 1,000 subchannels are not readable on a perfectly clean and normal CD. With no scratches, just open new, it is normal, I repeat, completely normal to have 1,000 unreadable subchannels. That's just how it works. You can reduce the speed to get more correct subchannels, but there is absolutely no guarantee that you will ever get all subchannels from a CD. Like, you can try several times, several drives, and you will never get them all. It's completely normal. Now it has finished completely. It has created the metadata sidecar file. This is the metadata sidecar creation phase. And it took about 3 minutes with an average speed of 10.999 megabytes. No sectors gave an error, and the subchannels that could not be read were just generated, so there are no subchannels that could not be read. So please save your questions for after I finish the demo. In case the last track is audio, you may see a message indicating that the layout could not be crossed and the dump may be incorrect. This is because the disk needed an offset correction that required data that the drive thinks to be beyond the end of the disk and didn't allow Aaru to read it. Many times this is just fine. This is just silence and the dump will be correct. If you see this message, you need to find a drive where it doesn't happen. We're working to make more drive models to support reading this data as soon as possible. So now let's go to the File Explorer and see what files are created by a dump. So first of all is drivercd.aaf. That's the image file proper. Depending on the image format, some may have more than one file, but in the case of Aaru format, it's just this one. The next file should be this one, but the order is changed here on this file browser, so I will just do as I have planned. So this is drivercd.cicm.xml. This is the metadata sidecar. It contains information about the disk contents and can contain information about the disk itself, like manufacturer, publisher, etc. As I said before, this is designed for machine consumption, for database systems of archives, automated image processing, etc. The next one is drivercd.error.log. Like its name implies, it is a log of all read errors, including the exact error reported by the drives. Sometimes, in case of read errors, this file can give hints at what happened, but if you are satisfied with the dump, you can just delete it. drivercd.ivg is the img barn log file. This file contains speed statistics and can be used to print a reading speed graph using tools found on the internet. Support for this file will be added in Aaru 6, but you can delete it if you're not interested in having speed statistics saved. drivercd.log contains the dump log, more or less the same information Aaru prints on screen while dumping. This can be useful for archiving, upload alongside hashes to some databases. It's your choice what to do with the dump log, really. drivercd.mhddlog.bin is the mhdd log file. It is similar to the img barn, but it contains different statistics that allows to draw a red difficulty map instead of just a speed graph. Again, don't need this file if you don't want this kind of statistics to be saved. Driver cd.resume.xml contains the information that allows to resume the dump at a later time on another drive. You can erase it if you're satisfied with the dump. And finally, driver cd.sub.log contains a log of all subchannels, if they have been fixed, what fixes applied, etc. This is a big file, but it's there only for you to manually check if so inclined the subchannels on the dump. So now let's go back to the command line and see what Aaru can do with an image. So we'll do Aaru image that's help to get all the possible commands. So the commands we have are checksum, that calculates the hashes of the image and prints them on a screen. Compare, where you can compare two different images and see if the contents are the same or how they differ, even if they are in different image formats. Convert, that allows you to take one image and convert it from one format to another format. Create sidecar, that allows you to create the CICM metadata sidecar from any image, even if it's not an Aaru format image. Info shows you information about media image and the media it contains. Options shows you all options that you can change in the dump phase using the options parameter, depending on the image format you're going to use. Print will print a hexadecimal show of a sector in the console, so you can see, for example, some dump groups require you to paste the raw contents of the ISO, the descriptor of the ISO volume descriptor. So using print, you can just get it indicating what sector it resides on. And verify verifies that this image integrity and if supported the sector integrity. So the first thing we're going to do is to get some information about the image itself with Aaru image info driver cd.af. Because we dump a CD, the first thing we're going to get printed is the table of content as is it saved on the image. It should not differ much from one we got from the media info. Is mostly like how the formatting is set, but it's the same information. Then we have the image sessions, that this only contain one session. The image tracks, again, this only contain one track. The track indexes, that only contains the index 1 and the pregap, and the hardware information. So this tells us what hardware has been used to dump this disk. In case you resume a dump with another drive, you will get both drives here. And you can see there is no serial number stored here because we use the private command line. So now let's verify the integrity, because it is known that in some cases CD drives can return a sector as read properly when it is indeed error. So for doing that, we're going to do Aaru image verify driver cd.af. Now it's checking all the sectors. It's going to take a little, but not much, less than a minute. Now that it has finished, we get a summary. So we can see that these image checksums are correct. This is for some image format like Aaru format, MAME CSD, that contains checksums about the image itself. Now we see a resume of the sector checksums. So this is the total number of sectors that have been checked. This is the number of sectors that return an error. 0 in this case, this is the number of sectors that didn't have error detection when dumped. Right now, only CDs have them. So if you try audio CD, so only data CDs have them. If you try an audio CD, if you try a DVD, all sectors will appear as unknown, as this is the sum of total errors and unknowns. If the dump didn't give any error and you see errors here, we're working on fixing that for Aaru 6, so we can detect that and consider them as dump errors without trying that. Now let's convert the image to another format, because right now the Aaru format is just a preservation format. It's not supported by any kind of emulator, and you may want to use the CD-on emulator. The most common format is the CDR Win Q sheet, so we're going to convert it to that format. So image convert, and it is very important to have the --force option, because when trying to convert an image, it will stop and tell you there are some things on the source image that cannot be put on the destination image. When the source image is Aaru format, unless the destination image is also Aaru format, it will always need force, because Aaru format was designed precisely to store things that no other image format can be able to store and preserve. So now I'm going to convert driver cd.if as the first parameter, and then I'm going to do driver cd.q as the extension for the CDR Win Q sheet. You can also use this to convert any other supported format, like for example alcohol format, to a Q sheet or to Aaru format to store it compressed. It has finished very fast, and we can see now here that we have the driver cd.q and we have the driver cd.bin. Those two make the CDR Win Q sheet image. Sorry. Now that covers all important commands to work with the image itself. So let's see what can we do with the contents of the image. So those will be the Aaru file system commands. So Aaru file system that does help will list them all. There are fewer commands here, but the most important ones are info. This will analyze the image contents and tell us what file systems and some critical information about that file system if it is found unknown. List will see if the file system is supported, what are the contents of that file system. And extract will extract the file system contents to outside of the image. So now let's try with Aaru file system info driver cd.if. So here we can see that it has found a partition that belongs to the first track. It has been identified by the ISO 9660, so 9660 file system, and it contains an ISO 9660 file system. And this is the volume descriptor. Please note that every single time Aaru shows you a datetime, like here that shows you the creation date, it will do the same as the operating system. That is, it's showing me my local time zone and datetime as I'm right now. If you just take this image, run it on your time zone, it will show a different information. This is how all the operating system works. If I come here and check here this file and just get the properties, I'm getting it on my time zone, not on your time zone, not on the universal time zone. It's in my time zone. So Aaru just does the same. If you want to see this information on the universal time zone, that information is inside the sidecar. So humans expect to find the time zone as we're living in. So anytime, any day you get, you're expecting it to get on your time zone. Machines, however, expect it to process the raw time zone. So any information printed on console is going to be directed to humans on your time zone, and the sidecar contains the information as raw. Now let's see what files are contained in this ISO 9660 file system. So Aaru file system ls driver cd.af. So here we're seeing all the files that are contained inside this CD using the image. So the CD is here, no tricks. I will leave it here. And here the format how it's printed by Aaru is first we get the directory. Aaru will always print using forward slashes even if you're in Windows. And then we have 3 columns. The left column is the size in bytes of the file. The middle column is a unique number, unique identifier for the file itself. And the next one is the file name. So it's very similar if you do dir on Windows. In case it's a directory, instead of showing the size, it will just show dir between quotes. And now, okay, we know what files are, but we want to do something with them. So let's just extract them with Aaru file system extract driver cd.if and a destination folder that must not exist. So you see now it's just extracting all files. Going to take a little, not much. Okay, finish. And now if we go here, we can see the folder it created. It says ISO 9660, HPBB, that was the volume name. And here we have all the files. Because this is a driver CD, there are not any file that can be shown. I mean, the setup is here. We're running on Linux, doesn't make much sense. I'm not going to install the drivers for this HP printer right now. But you can see it has extracted all files. So what usefulness this have? Well, for this file system, obviously you can just mount the drive and extract that. But the difference is that Aaru supports things that your operating system may not support. For example, if you're on Windows, you do not support Rockrich standard for file names and directory names that Linux does support. Aaru will support that. And you can also have the Romeo that changes the encoding of a ISO volume that Windows supports and Linux doesn't support. So this is the advantage comparing to just drag and dropping. Also, Aaru supports file systems that are archaic, all like Lisa file system, the OS2 variation of the file system that are not supporting in any current operating system. So this is why it's better to extract the image with Aaru than to just copy from the CD, DVD, or any other kind of media you have. And so this is like all for the demo. I was not preparing to have 2 hours of streaming, but this is what happens. So if you have any questions, now is the time to ask them. Or if you want me to demo another command I have not talked about, maybe we can talk about it. So please put all your questions now on chat and I will start reading them. So there was a question said before by Mustache Boyo. Doesn't Flash media have a lot of tiny errors? No, it shouldn't. So the thing about Flash media is that depending on the exact technology, it degrades on a very specific manner. Usually the way it degrades is that it becomes read-only. So you get a flash drive, you copy some files to it, apparently it copies everything. You go to another computer and you see nothing has been copied. That's usually how flash drive degrade over time. But not having tiny errors, that's not normal. You have tiny errors on a flash drive, it's like having scratches on a CD. It's not normal to have tiny errors. So another question here. What inspired me to create Aaru? Well, the thing is that I have always been fascinated by archaeology, specifically Egyptian archaeology. So how everything is audited, noted, saved, stored, processed, there's nothing left. So when I started with my passion about preserving computing history, the first problem I saw is that most software for dumping disk of any kind, not just CDs but also hard disks, they are more like created for one or two purposes. The first one is usually piracy. Alcohol was created for piracy. Alcohol was not created for creating your backups. Alcohol was created for piracy. And for CD, somewhere like DD is created just to make a copy. So it doesn't really want to preserve everything about the media. It's true that there are some things about the media that you may consider not well for, but Aaru is designed the same way as Egyptian archaeology is made. When archaeologists find something, he doesn't ask, is this important? No, he just takes it, stores it, and let history decide if that artifact is important. So that's the, how to say, the philosophy of Aaru. Aaru will store everything, absolutely everything, out media that can be read with your environment, hardware, etc., and let you decide what do you want to store or not, what you want to preserve or not. But Aaru will just read everything. Like, same as in Egyptian archaeology, it's not the decision of the archaeologist if something is important for history or not. So that was my inspiration to create Aaru. Indeed, the name itself is means the reed of fields, the field of reeds. Sorry, that's the Egyptian concept for the afterlife, for the paradise. Because the intention is that this software preserves your media for history, preserve your media for being investigated later, for being talked about later. For that, you cannot decide right now, before that happens, what is important or not to preserve. So I will always try to preserve everything it can. So I hope that answered your question satisfactorily, Sadikio. Exactly, Sadikio. That's how it does. So Aru brings to the digital world, to the preservation of digital media, the same philosophy used by archaeologists and historians. So how do I see Aru fit in archivist workflow? Well, it's already being used by some museums, and exactly as I say. So the idea of Aru is to provide everything archivists will need. So obviously the first step is to archive something. So it may be, as say, a real CD. So you dump it, you get all information from that CD storing an image that's designed for auditing, for preservation, for taking as less space as needed, because archivists are not rich usually, so we don't have a lot of space. So the smaller the image generated are, the better. And as I say just now, store absolutely everything. Then it also allows to process any image. So we have seen everything done with my image format, but I can just do absolutely the same. So file system ls, like we did, but instead of using the Aaru format, I'm going to use the Cedar Winky sheet. I will show exactly the same right now on screen. Because the thing is that sometimes we don't have access to the media. Sometimes we just get an image made by someone else, and we still need to process it the same way. So Aaru can do the first step, dumping the media, or can just start on the next step. And then usually the next thing that is interesting about for archives is what is contained. So that's why Aaru tries to implement file systems in a way that's much more powerful than any operating system. As I said before, I spoke a little about the OS2 variant of the FAT file system. So the FAT file system is usually what's used on flash drives. When you format a flash drive on Windows, you will just get FAT32 file system. But the thing is that this is how Windows uses it. The FAT file system has been used from its inception in the 80s by almost all operating systems, and each of them has made a small variation. For example, the Macintosh the old Macintosh, not macOS 10, not macOS 12, but the old macOS 8, macOS 7. When writing files to a fat file system, it needed to store things like the resource fork, the icon, positions, and so on. So all of that information that you may find on archive, Aaru is able to extract it and show it in a way that modern systems, even if they support that file system, will not. And so having the sidecar generation that is used for machine consumption, we allow to integrate all this workflow from Aaru and automate it so you can use it on whatever the museum software, the museum archive management software is. So we know, for example, that the Computer History Museum on California doesn't use it to dump because they mostly use floppies, and that's still not supported by Aaru. We're working on that. But after the dump has been done, they use Aaru to extract the contents and create a metadata sidecar that then they use their own software to store on their database of artifacts. So that's what I see it. I see it as the software to be used by archives and museums workflow from the start, from the media itself up until the point that we're storing all the artifact information in the database. So Aaru goal is to provide all the information that is needed by an archivist for their database. So I hope that answers that satisfactorily as well. Sorry. So any more questions? We have almost an hour left for questions. So yes, I mentioned Aaru 6, and Aaru 6 is very far on the horizon. So right now you should just use the latest stable release, that's Aaru 5.3.1. Because with Aaru 6 we plan to, the most important thing is a graphical interface. So there are many people, that archivists that are not as said, well versed on the command line. So with Aaru 6 we plan to introduce a graphical user interface so users not versed on the command line can still use it with the same easiness. That's the most important change. We also have plans to support floppies, to support dumping with, for example, Pauline, CryoFlux, SCP, and other kind of flux dumpers that right now are completely unsupported. And we also plan to improve the Aaru format image, because right now it's not designed to store very big, like more than 160 gigabytes disk. And we found that some archives are already using Aaru to store like 2 terabyte disks. So this is our major changes we're planning for 6.0. So what are my dreams for the future of Aaru? Well, my dream really is that I have a lot of users, a lot of input, but not just that, a lot of help. Because it's not about money. So Aaru is not a project that really right now needs money or donations or anything like that. What I need is developers. Because there are many features, there are many bugs, there are many things to fix, to implement, that need time that I don't have. And the other two developers I have with me don't have much time also. So what my dream for the future is to have a team of developers that I can guide on the features we need, and a bunch of users, museums, archives, and so on, telling us what they need for archival purposes. And please don't confuse, we will never do something that makes an archival worse. So we have been asked sometimes to modify the image because this other software does like this. We always target for correction. So if you want to have something done well, you need to have some limitations on how you do it. and forget what has been done before, and maybe bring compatibility with how some groups expect the dumps to happen. But we target correctness, we target completion, and my dreams that will be having a team that can lead to achieve that completely with all the file systems. We know that about 50 file systems that can be implemented very easily. Yes, I don't have enough time to do them all and support all the kind of media and fix all the bugs we receive from the users. So is it possible to dump multi-session disk in version 6? It is possible to dump multi-session disk on version 5.3.1 if you use Aaru format. The problem with multi-session is that all other kind of formats are not really well described, and we had some problems trying to understand how multi-session disks are stored in that format. That's why it's disabled. But if you stay with Aaru format, you don't convert it to other format, you can dump multi-session disks right now on version 5.3. On version 6.0, we will work to reverse engineer other formats like alcohol to add support for the multi-session formats. But right now, you can just dump them on Aaru format. There's no problem to dump them on Aaru format. So, any more questions or? Yes, I think I've known, but as I have just said, not enough time. A graphical interface for something as complex and with so many parameters as Aaru is not something you do in an evening. So I'm working on that. And if I get people to help, better. So anyone else has any question or? Thank you, thank you. That's why I wanted to do it. Well, it seems that there are no more questions. So I will finish earlier and Jonas can start because I was prepared this for 1 hour and then there's not much more I can show unless I just show the same and the same and the same. As said, please note that all of that I have shown now works exactly the same on Windows and on MacOS, except that dumping is not possible on MacOS. So this software is completely multi-platform, and I hope you like my demonstration and you like my software. I've been doing this software for 10 years, so it's not just work, it's already something emotional about it. And if you have more questions, you can find me and my team in Twitter and Discord. Our Twitter handle is Aaru_DPS. I'll write it on the chat as well. So So we had a new question here. Larsen is asking if Aaru will be accepted as a dumping tool for redump submissions. So ask that for redump. As I said, I will not modify the output just to belong to what a group has been doing wrong for all this time, not particularly redump any group. I will always target for correctness and for completion. It's not my responsibility to get redump or any other group to accept dumps from Aaru. So I cannot answer you that question. If they will ever do, I don't know. They know. Ask them. So as I was saying, I'll have left our Twitter handle on the chat, and you can find me in both the HitSafe and the Video Game Preservation Collective Discord servers, being the later the official one for support. And well, if Jonas can please take over, what were you going to show about preservation? So this has been all. Thanks for watching me. Jonas, all yours.